Okay. Hello, everyone. I'm so excited to be here at CSSconf and talk to you all about the algorithms of CSS. What is this talk going to be about? Hello. So my name is Lara Schenck, and that's my Twitter handle. I am a freelance WordPress and front-end developer, and WordPress and CSS are kind of my two loves, as well as teaching. I love teaching. I love sharing what I know, and I also love using teaching as a means to get myself to learn things, which is kind of what I did with this talk. So, CSS. It has a special place in my heart, as I'm sure it does most of us here. I have a background in art, and I came upon CSS through kind of a weird college art project, where I wanted to turn it into a video game. And that kind of morphed into making WordPress sites for money. And that eventually turned into a career I really love. And computer science didn't really turn up in my career until about 3 years ago or so. I kind of got really good at making websites, but didn't necessarily understand what was happening under the surface. And this showed up in the form of an algorithms interview. How many of us have done an algorithms like whiteboarding interview before? Okay, good amount of hands. So it's like questionable interviewing style, but it exists. So that was kind of my first encounter. I definitely failed it. And then about a year ago, I got an interview for a job I was like very excited about, and I was like, okay, I got to take this one seriously, and I got to learn about computer science. So I really grew to love it. And the connection between computer science and CSS wasn't always clear. Like, I saw the connections between my work with JavaScript and with PHP quite often, but with CSS, it was kind of hard to bridge that gap. So in the spirit of committing to teach things in order to learn them, I proposed this talk for CSSconf EU. And I started my research for this about 6 months ago, and CSS really went from something like this. So gray, like, I was like, oh, I gotta write CSS. Like, it's just not as interesting as this other programming stuff I'm doing. And then over this 6 months of research, CSS became like, oh my God, CSS is so cool. Like, this is the dream. This is awesome. And in addition to this kind of like revitalization of my love for CSS, my code got a lot better and a lot more intentional. And I think I write code faster now too. So I want to kind of share with you all how I got to that point and my journey in this research. Okay, so I started all of this with a question. Is CSS a programming language? How many of you have thought about this before? Okay, good, nice number of hands. I'm going to follow this up with a little fire emoji because this is a little bit of a hot topic lately. And I posed this question on Twitter. Is CSS a programming language? And the results were about as expected. 42% no, 50%, or rather 42% yes, 50% no, 8% I'm not sure. And the responses to this tweet were interesting. The yeses were kind of like, yes, absolutely it's a programming language, or like, for sure, CSS is a programming language. And the no's were more like, I don't know, like you can't really call programming a web page layout. You don't really say you program in CSS and HTML. It's just like not really what it's like. So kind of mulled this over, and I was like, okay, stop. Like, I think we might be getting some opinions and like personal experience mixed up with facts here. So let's start by asking, what is a programming language? And groundbreaking definition coming up, a language of instructions for a computer. So the thing is that the definition of a programming language is kind of intentionally vague, and there are many, many types of programming languages. Soon after reading about the definition of a programming language, one would encounter programming paradigms. And the term paradigm is really a word for like a general classification or model or style of doing something. And there are two main classifications in programming paradigms. There's imperative programming paradigm, which refers to code that tells the computer how to do something. And there's declarative, which is code that tells a computer what to do. So these are two fundamentally different paradigms, and they are the two main umbrellas. And so with paradigms, languages can be categorized under certain paradigms, but they can also describe like styles of the code that you're writing. So for example, you might be writing JavaScript in a more imperative style, or you can write it in a more declarative style. So they can be high-level terms, but also terms for specific definitions. And the two, or rather the main difference between imperative and declarative languages is the presence of control flow in imperative languages. And control flow refers to the ability to manipulate the order of execution of statements in a program. And that happens via things like if statements and for loops in a very literal sense. So the computer would read your program kind of top to bottom, and then based on your program, it would maybe jump up to different parts of the code. So you're manipulating that order of execution. And declarative programming does not have control flow. So any logic or iteration is kind of baked into the actual instructions themselves. So like what you're telling the computer to do is declarative. OK, what are some languages that fall under these categories? Imperative languages are what we usually think of as programming languages. So JavaScript, Ruby, C++, Python. Generally, if you think of a programming language, it's probably an imperative language. Declarative languages, on the other hand, are oftentimes domain-specific, which means they've been developed to function within a certain context and within a certain domain. What are some domain-specific programming languages? SQL is one. So SQL is a domain-specific declarative language for working with databases. HTML, what? Sure. HTML is a domain-specific declarative language. And of course, CSS. OK, I'm sure there were people who would be like, what are you talking? Like, no, just no. Like, CSS is not, doesn't count. Whether you want to argue like CSS was never intended to be something like a programming language, or perhaps that the browser can't really count. The browser just parses; it doesn't do anything else. To that, I would say like CSS plus HTML is also Turing complete, and Turing complete refers to the ability to solve a computational problem of a certain complexity. CSS can also do math. Like, that's cool. Functions and variables CSS also has. But ultimately, I would say, like, why not? So why can't CSS and HTML, for that matter, be part of what we consider programming languages? So the idea of kind of disqualifying HTML and CSS leads to disqualifying all of declarative languages. So I think that discrepancy comes into play when people are misinterpreting what imperative versus declarative is. Further, the web at large is really declarative in nature. So if we had to describe in our programs how a computer is supposed to, or how a browser is supposed to open a connection to a server, that would be like very, very intense and totally inaccessible. So the power of declarative programming is huge, especially when it comes to APIs and anything we do on the web. OK, so hear this loud and clear. CSS is a domain-specific declarative programming language, 100%. And another one. We as CSS developers program the layout of web pages. I'll give that another 100%. So referring to what I would do as a CSS developer as programming, has taken a long time to get used to that. But as I learn more and more about how computers work and how a browser works, the code I write, I think, can totally count as programming. OK, now we've established, got that all the way. Let's talk about algorithms. Algorithms 101. Yay! OK, let's have another definition. An algorithm is a well-defined computational procedure that takes input and produces output. This is a definition taken from Thomas Corman's Introduction to Algorithms, which is one of these large textbooks assigned for computer science courses. Dense, very informative, maybe not a great intro. But hopefully this will be. Let's use this framework to talk about algorithms. So we have inputs, unsorted list, and we have outputs, maybe a sorted list. So what is the algorithm in between there? Well, sorting is certainly a solved problem in computer science. We have lots of sorting algorithms. Bubble sort is one. That's a great name. Not the most performant of sorting algorithms, but it's excellent. Selection sort. We also have merge sort and quick sort. Let's take a look at an implementation of one of these, just to kind of take a look at what an algorithm is under the hood. So why not? Bubble sort. This is what a sorting algorithm looks like, if anybody's never seen one. So let everybody read for a moment. Wonderful bubble sort in all of its glory. So we can see this is imperative JavaScript here. We're really telling the computer how to sort. We're giving it step-by-step instructions to be read top down, and the control flow is there, so we're kind of jumping back up to certain statements where necessary. I'll give this a heart because I like JavaScript. If this were a declarative program, this is all we would see. OK, back to our framework. How would algorithms or algorithmic thinking like this apply to CSS? OK, let's say we have a stack of elements, so to speak, and our output would be a row of elements. What would be an algorithm we would use in declarative CSS to get there? Oh, sorry. What would be an algorithm we would use to get there? Display flex, sure, why not? That's totally an algorithm. Or perhaps float left, gasp. OK, let's take a close look at the implementation of this algorithm. OK, there it is, display flex. That's declarative CSS. So I'll give this a heart, because that's amazing that we can just, that's display flex. OK, I just did a ton of stuff, and I didn't have to write all that code. I didn't have to write that how. So that's the power of declarative programming. It's kind of the dream, I think, what we do with CSS. OK, so the thing is, there is, of course, a how to declarative programs. We write the what, and we need to understand the how to make our code better. Let's have an iceberg metaphor. OK, so let's say we have declarative on the top and imperative at the bottom. So when it comes to CSS, the imperative part is going to be the declarative part is going to be our iceberg at the top, and the C++ and Rust code that lies within a browser's rendering engine is what we have at the bottom. So as I was learning all this, I'm like, OK, I want to look at this imperative CSS. What is that? What is there? So I started by taking a look at the Cascade. We love the Cascade in CSS. So not only is the Cascade wonderful, it's also the first thing that shows up when you search algorithms and CSS. So Cascade, an algorithm that combines property values from different sources, that is from Mozilla Developer Network. If we place this into our algorithms framework, we start with inputs from different sources, and our outputs are combined values from those different sources. And what's the algorithm in between? What happens in between? So we sort by importance and origin, sort by specificity, and finally, the order specified. And that winning value is what's then sent to the browser's rendering engine. OK, so I was like, OK, I understood the Cascade. This is not groundbreaking information. I'm guessing a lot of us here understand the Cascade. I wanted to see what it looked like, and I expected to find something like this, function, cascade, magic. And that's pretty much what I found. Function, cascade. Look at it. It's right there. So the thing is, this is more of a fun slide, because the Cascade happens in many, many, hundreds of, maybe thousands of lines of code throughout the source of CSS, and can't really be pinpointed to one file. But I was like, this is definitely going in the slides. OK, where did I find this code? I know you all are dying to spend the weekend looking through Rust and C++. So we can go to searchfox.org, which is a searchable repository of Firefox, as well as cs.chromium.org, which is the searchable repository of Chromium. And specifically, we want to look at the rendering engine in each of these. So in Firefox, that rendering engine is called Servo, and in Chromium, rather Chrome, it's called Blink. So Blink is the open source rendering engine there that's also used in Opera. So my process for looking through these source files was to read the spec very carefully, and I would kind of go step by step through this and map what I was reading in the spec to the source code, which was a nice process, because browsing browser source code aimlessly gets a little bit tedious. Another thing I want to point out that became way more apparent and meaningful were just the simple names of what we call things in CSS. So we're all probably familiar with the idea of selector, property, and value. But this is called a declaration. I often called this a rule. And this whole thing is called a rule. And it's really important to, or rather, these terms became way more meaningful after I had had this experience of looking through the browser. because CSS is parsed specifically to retrieve each of these values. Okay, so whatever, the Cascade, it exists in the browser, got it. This is when my CSS, this was when I kind of had this, enlightenment moment where I was like, CSS, and then I was like, oh my God, it's so cool. I see all this stuff happening underneath, this is wonderful. So, and I think that's where, every line of code I would write, I'm like, I see this other part, and it was just amazing. So I suggest it for everybody. I want to look at a specific example, and to get back to algorithms a little bit more, and about how my code and my style of writing code changed after this. So this was a wonderful mock-up that I received from one of my clients, who's an agency, and this is a drawing of the mock-up. Let me be clear. And that is a high-resolution image of an ocean on top, if you can't tell. So the design was done really well, really intentionally, kind of developer-friendly, and we talked about how this design would break down. And we were going to have two different images here. So the bottom would be this transparent PNG, and the top would be a compressed JPEG, and then all the sizing could be done with aspect ratios and whatnot. So I started coding this, and everything was great. And then I was like, oh, crap, the ratios are really different in the mobile comp versus the desktop comp. And I was like, this is frustrating. This is a fun challenge. Okay, but I'm getting annoyed. And I began programming my CSS with a hammer. So if anybody's sure, we've all done this before, where you're just like, oh my God, work. And you just kind of keep trying the same 10 things over and over in your head. And you're like, it's kind of different, but not. But maybe it'll work this time. So I was like, OK, stop. Don't do that. I'm writing this whole talk about algorithms and algorithmic thinking in CSS. What if I break this down into an algorithms problem? So what are the inputs? Beautiful ocean image number 1. Beautiful ocean image number 2, and my viewport, of course. And what are the outputs? Everything smashed together, because as CSS developers, we are programmers of boxes, essentially. So what position are those boxes going to be in? Now I had to write an algorithm for this, and I was like, oh, crap, how do I write an algorithm? Well, I've been studying for these ridiculous whiteboarding interviews. Here are the steps you take to write an algorithm in a whiteboarding interview. So step 1, you plan it out. You plan out your inputs and your outputs, and kind of what steps you're going to take in between. So pseudocode. And number 2, you come up with a brute force solution. And your brute force solution is a not performant solution for the algorithm. You're kind of just getting it done, getting it to work. So with something like brute force search, you would, rather than algorithmically or efficiently group certain elements and search in a more strategized way, you would just go step by step, is this the one? No. Is this the one? No. Is this the one? No. So that's the idea of brute force. Third step, you would walk through, so check and see if your algorithm works. Fourth step, optimize your solution. So apply different strategies for algorithms design to whatever your brute force solution was and kind of refactor it. Okay, great. So planning, kind of talked about the inputs and outputs already. I took to my whiteboard and figured out how I wanted these boxes to change at different viewport sizes, and then came back and mapped out different values and different behaviors that I wanted for this specific layout. Then I jumped into some pseudocode. I was like, OK. And I was like, pseudocode for CSS. Cool. That's not something I usually do, but this is really helpful. So number 2, I will go to my brute force solution. And another word for brute force solution is spaghetti. So spaghetti code. I was like, oh, OK, this brute force step is when you have permission to write bad code. It's oh, it's OK. I don't have to think about all the naming conventions and everything. I just want to figure out the solution to a problem. And I had never really approached CSS that way. That's how I would approach JavaScript and PHP, but that's not something I did in CSS. Brute force CSS, what do we got? Smelly CSS. So what are some qualities of brute force CSS? Is it part of a system? No. So if you're working within a design system, I'm not sure how many of us have the luxury of doing that, but scrap your design system for a second and just be like, oh, I got to figure out this weird problem. I'm not going to try to do it within the confines of this system, which is wonderful, but it's a hindrance right now. Magic numbers? Absolutely. To-do comments? Absolutely. Does it work? Maybe. But pretty much, you're figuring that out, so it might work. Step 3, walkthrough. This is when we can do that wonderful browser resizing that we developers love to do. Not sure if users do that, but we like to do it. So make note of what works and what doesn't. Then fourth step, optimize or brute force CSS and refactor. So optimize is code for refactor. So we take our wonderful smelly CSS and it magically transforms into a beautiful flower of optimized CSS. You can look free to I know. I might have had the most fun making this slide. I was like, this one's going to go down well. OK, so optimized CSS. What are some qualities of optimized CSS? Part of a system, yes. So this is when you have your brute force code. You're like, oh, gross. But I'm going to massage it back into the design system or the naming conventions that you're using. Uses algorithms. So does it take advantage of the intrinsic algorithms that are baked into CSS? So like CSS grid algorithms. Intentional cascade. I like this one because obviously I love the cascade after doing all of this. And so I'm like, how can I use the cascade here? Cascade and inheritance. It's like baked into the name of CSS. Let's use it. To-do comments. They're not all going to be gone, but a lot of them will be. OK. A small note here. This is kind of, to me, we all write CSS differently. All of our teams write CSS differently. So these are kind of some qualities of optimized CSS that I shoot for. OK, I'm going to show a little bit of code here and preface it with a yellow light because this code is taken out of context and might not make entire sense mashed into a slide. But these are things I kind of consider algorithms in CSS and ways I've followed this process to solve a problem. So this is the solution to the ocean boxes issue. Then we have a centering algorithm. And finally, yeah, FizzBuzz! Yeah, I failed FizzBuzz in an interview like 3 years ago, and so now I'm like, all right, take that, FizzBuzz and CSS, do it. So if anybody gets asked FizzBuzz in an interview, please write it in CSS. And if you're not familiar with FizzBuzz, it is one of these kind of beginner algorithms questions that is intended to stump people. It's not very nice. It's well-meaning initially, but I don't know. So after doing all this and kind of figuring out this new process for writing CSS for myself, I was like, oh my God, did I come up with a new thing? Could this be algorithms in CSS? Is this a new way of writing CSS? Or maybe, I was like, I got to give it a name. Maybe algorithmic CSS? Or maybe intrinsic algorithmic CSS? I was like, maybe. And then I was like, OK, maybe I just got better at writing CSS. So. But I think I'm interested to hear from everybody kind of after the conference, how you use algorithms and if this makes sense. OK, so I want to wrap up a little bit with a tip that I think anybody who works within this design to development process can hopefully take back to help smooth out that process. Because, unfortunately, it is not all puppies and kittens. I like that expression. So here's a designer and developer, puppy and kitten. So I think that we can use algorithms as a common term to talk about how our designs are supposed to respond across device sizes. And of course, I don't want to leave out the designer-developer. Algorithms, yay! OK, so what would this look like, I guess, this conversation? So we think about we have small screens, OK, and we have big screens. And we have a component here that is changing based on the screen size. So I think in this conversation, this design to development conversation, whether it's just with you as one person or with a group, with a team, we can think about the resize rules. So what are the resize rules? What's the component resize rules for this particular element? Or, algorithm, maybe. Try it on for size. Oh, here's a little example of one of my projects. One of the agencies I work with was doing this already. And I was like, OK, that's great. I'm going to put this in my talk. So they would kind of include a little description of a component with the design for the pattern. And I was like, awesome, pseudocode, done. I don't have to do this part anymore. Because if we go back to our 4-step algorithms writing process, our planning step is done now. That's great. And here's the resulting algorithm for that little bit of code. Magic? Maybe. OK. Yay. Conclusion. Here we go. OK, if you take away one thing from this talk, it is that iceberg metaphors are amazing. Okay, just kidding. But I want it to be that the code we write is kind of at the top, the tip of the iceberg here. So it's what we see. And how it works is all the way down there. So it's not something we necessarily see, and it's something we have to seek out and try to see for ourselves and kind of fill in those gaps where we can. And filling in those gaps and kind of constructing the bottom of the iceberg will really help the code we write at the top be a lot more informed and a lot more intentional. I also had this idea for a really annoying app that would be the mindful CSS bell. And it would go off every 30 minutes, and it would kind of catch you and make sure you're not writing CSS with a hammer. And it would say, like, read the spec. So it's like, do you understand what this little line of code is doing that you're writing? So I haven't made this app, and I might not, but that's an idea. So at the end of the day, did I bridge the gap between CSS and computer science like I intended to? Well, I think it was a lot more like this. So we have computer science, and within computer science, we have CSS, and we have C++, and we have HTML, and we have JavaScript, and many, many other things. And so it really, I don't know, it's all great. I love it. Okay. Yay. Thank you, everyone. And this is thank you. This link is linking to a blog post where it's a very large compendium of a lot of the sources I used for kind of learning how a browser works and learning more about computer science. So thank you all. Looking forward to talking to you later.